Go live. All right, so this is just day 2 of 314, evaluating trig functions, and we used the unit circle and a triangle we created in order to find the trig ratios. And at the end of today, I want you to see that we're just dealing with that triangle. That's the main thing we're trying to create and get information around. We use the unit circle sometimes. You're going to see when we don't. Okay. So here we have the warm-up. We have a blank unit circle. When theta equals 4 pi over 3, we're trying to find the reference angle. So first off, 4 pi over 3, is that greater than 1 or less than 1? Greater than 1. So I know that if I start on this side of the board, I go that far, I get to pi. So how much further do I need to go? Essentially what I got to is 3 over 3 pi. How many more thirds do I need to go? 1 more third. So that's where I'm going to just get rid of our y-axis down here to break this bottom sector into what? Thirds, right? Thirds. So we have 3 equal parts there, and I know if I need to go theta 4 pi over 3, I need to go 3 over 3, that's 1 pi, and then another third. So essentially we're going all the way around here to get to 4 pi over 3. But the thing with this is, every single time when we are drawing information from the unit circle to get to our triangle and our trig, every single time we're going to look at the reference angle. The reference angle is always going to be the theta that we're going to use. So watch. The reference angle is always how to get up to the x-axis the quickest. Okay. If I had one up here, right, this would be the quickest way to get to it. That would be my reference angle. If I had one right here, that would be my reference angle. You see how it's just how quickly can you get to that x-axis? That's the main thing. The unit circle allows us to identify what the theta will be. What the theta? Sorry, get rid of this. So we know this is our terminal side rotated from our initial over. So theta in this case, right, would be that reference angle here. Once you've identified what theta is, in this case we actually know that this theta is pi over 3. Sorry, it's so small. Pi over 3. So what I'm pointing out here is, if we were given a coordinate out here, which was what problems 1 through 4 was, if we were given a point out there, I know this is my theta, so naturally I'm going to be creating my triangle this way. Okay. Now we just have a triangle we can pull out, but we have one detail to master before that. So before we do anything extra, we need to look at what quadrant this terminal side is in. Okay. So this terminal side is in which quadrant? Third. That's going to be key information once we get through this next panel over here. Okay. So looking at this next panel, first off, I need you to remember this if it's not clear. So write this note down if it's not clear. The cosine of theta is associated with my x value. Right? The sine of theta is connected to my y value. The other one I want to point out is that the tangent of theta is equal to the sine of theta over the cosine of theta. Essentially what we're saying is the cosine, or the tangent of theta is the change in the y, or excuse me, the y value over our cosine value, our x value. That's going to come into play in a second. Now, why is this useful? I'm actually going to tell you why it's useful first. Okay? Yeah?
Can I answer that, John?
Yeah. All right, why is this useful? Based on the location of the terminal side, right? The terminal side, right? Based on the location of the terminal side, we can find our answer if our answer is positive or negative. Because I want you to remember, when we break it down and we bring it over to a triangle, let's say we have this triangle now that we were kind of building. I know that this is my theta, right? If I knew that this point down here, and let's say this is the origin, right? If this point down here is negative 5, negative 10, what should I put as my value for this? That's along the y-axis. What should I put? 10. 10. We don't put negative 10 because? you can't have a negative side. I need to move this. You can't have a negative side of a shape. Think about if you were trying to cut pizza up and you made them actually into triangles. Could you make one side of your pizza a negative distance?
Yeah.
Impossible. You could eat it and then it becomes negative. It's true. No, that's not what I was getting at. So what I'm pointing out here is that this is our 10 and this is 5. This is our hypotenuse always. The terminal side is always going to be the hypotenuse. Because the other sides are just found by looking at how far over with the x, exactly perpendicular over here, and how far horizontally, and how far vertically do I move as far as my y value. What's missing between my triangle and that point? What did we lose? What information did we lose when we translate it into a triangle? What's different? This is positive 10. This is positive 5. So what's different? The signs. We lose some information on the signs, right? So you can't have a negative side to a triangle. We lose the information on the sides. So what we're going to discover now with that left board, we're going to be able to figure out if the answer is going to be positive or negative. We're going to keep that information, and then at the end for the answer, we're going to say if it's positive or negative. Because we lose information about the positive and negatives when we translate it into a shape. Okay? So let's go back. That's it. All right. So think about this. I just broke down that the cosine of theta is our x values. The sine of theta is our y values. So if I look at this, somebody describe to me or tell me why in quadrant 1 the sine of theta is going to be positive, the cosine of theta is going to be positive. Why is that the case? Talk with your neighbor. Give you like just 10 seconds. Get an idea out. Get an idea out. Why is quadrant 1 sine positive, cosine positive? Why? Got it? Are there any teams that you're sure you feel pretty good about it? Both of you got it? Yeah, Sonia, help me out.
Well, like above the origin is positive, which means that the y value is positive, which is sine theta.
Perfect.
And then it's to the right of the origin, which means the x is positive,
Perfect.
and which is cosine theta.
Cosine theta. Is that pretty simple to think that out and figure that out?
Yeah.
Like if I didn't have all this stuff on the board, now you know what the game is. You could fill out the rest, right? What are my x values over left of the origin on both these quadrants, 1 and 3, or 2 and 3? The cosine, the x value is negative, so that's why the cosine of theta is negative in second quadrant. That's why it's negative in third quadrant. Okay. Sine, negative, because the y values are negative in this direction. That's negative 2. So you see, if it's above the origin, the sign is going to be positive because this relates to our y term. It's always related to the y's. Cosine is always related to the x. So on this side, cosines are negative. On this side, cosines are positive. Okay. The last thing I want you to do is, right here that I didn't ask you to copy, how about the tangent of theta? What is the tangent of theta going to be in each of these? You might use this over here as a guide. So talk with your neighbor. What are the tangent of theta is going to be? Positive or negative in each of those?
Yeah.
Perfect. Andreas, help me out.
So I think quadrant 1
Yeah.
and 3 tangent will be positive.
Nice. So you're breaking it all the way down. And tangent of theta is positive here because sine over cosine is what my tangent definition is. It's positive over positive. Good. And what'd you say elsewise? Or the other way?
Quadrant 3 is also positive.
Good. Because?
Because negative divided by negative is positive.
Perfect. What are the other two going to be then? In the other two, we have a combination of positive and negative. So if I put that in a fraction or with multiplication, I get the tangent as what? Negative. Over here. Tangent. the only last bit that we need to figure out is really intuitive as well. So honestly, you could make this whole thing knowing that cosine is my x's, sine is my y values. And you just look to see what quadrant it is and what value that'll have. Now, the other thing is secant, cosecant, and cotangent. Remember, this is just 1 over cosine. This is 1 over sine. This is 1 over the tangent. I want to iterate. I'm not sure if the confusion came out yesterday in this period, but this inverse is not equal to the cosecant. The sine's related to the cosecant, but we cannot use the sine -1 of theta. This isn't speaking about our reciprocal identities. This is speaking about if I know theta, I can take the sine of theta to find my answer here. If I know the answer here, I can take the inverse sine of 0.5 to find what your actual angle is. Okay, those are the differences. You actually, for this this classwork homework you have, you won't be using this function. I want to just clarify what that is. We'll touch this later this week. All right. Can't wait. So if I know that the cosine is positive in quadrant 1, what is the secant then? It's the same. You see how it's just on the bottom, but the full answer is going to be 1 divided by positive. Here, if it was over here, sine is negative over here, so it would be 1 over a negative sine. It would be negative. That one is more intuitive. It matches exactly with cosine, sine, tangent. Okay. All right, how about just as a basic skill to figure out, based on where my terminal side is, right? Here's my terminal side. Could we figure out if it's going to be positive, negative for any of our functions? Just as far as like if this was all you were trying to accomplish, how do we feel about this? Feel pretty good? Okay, if not, ask a question. Let's get a Candy Crux. What's the hardest part about that? Is there any? Are you guys? Yes.
Remembering like secant and cosecant, like which ones they correlate to.
Okay. So that's a little bit of memorizing. Does anyone have a mnemonic device they have already worked out to connect? Is it sine to cosecant or is it cosine to secant? Yeah.
The other way around.
No, sir. How does the sine relate to secant? But that would be where I would connect those, and I connect those well.
Well, if you know the name of like the inverses, like cosecant, cotangent, you know it.
I want to hear some more ideas. I think that's a good start. If you understand that, it's perfect. Just to pass it on might be a different thought experiment.
So this is a little complicated. It's for the last 3. So it's the first letter of each one. So Santa for sec, crawls for cos. Santa Claus crawls, and then you go to sis. I think that's how you say it. Through, that's the T. Someone's chimney tonight. Does that make sense? So you go like up and down, up and down.
Oh, like that?
Yeah.
That.
It's lengthy.
Santa Claus crawls
Through someone's chimney tonight.
through someone's chimney tonight. That's a cool mnemonic device. I'll write that down. Santa. Sign. That's not right.
Santa Claus.
Oh, Santa Claus. Okay. Claus. So secant, cosine, through some. Claus crawls. Sorry, this isn't intuitive to me. So that is cosecant crawls through somebody's. Jeez. Sine. Chimney. Wow. cotangent tonight. That's one way to do it. I like it. What else do we have? That was good, actually. Good Starburst. You want a Jolly Rancher or a Starburst?
Jolly Rancher.
Great. Hope you like it.
Thank you.
Anybody else have some come up? There's 35 creative brains in here. Yes! I know you got a good one.
You cosecant call signs in. Oh my god. Yeah.
Say it all again. Say it all again.
You cosecant call signs in.
Cosecant call secant.
Call signs in. Yeah.
Uh-huh.
Yeah.
Is that helpful? You got it? Yeah. Justin, can you write that down on paper? Like, how would you explain that on visual writing? Because I'm not seeing it auditory. What you're saying. All right, no worries. I'm gonna put it on you to find a good way to remember it. I think of the cosecant, right? The secant is like the basic. The cosecant is the more complicated one. Cosine, secant, sines. You guys come up with something good. Felt it?
This isn't like a word or a phrase or anything like that, but I just remember it as tangent and cotangent makes sense.
Yeah, that makes sense.
And then sine goes with cosecant,
Yeah.
and then cosine goes with secant, so it's the co and the s.
Yes.
It's just dots.
Okay. Okay. Yeah. What'd you have? Dean, you're next.
Sinners can't see cats.
Sinners can't see cats.
Cats. Because it's just putting sine and cosecant together, and then you just remember the other one.
Sinners can't. Right. See, where's cats though?
Well, it's just CSC.
Sinners can't see?
No, it's like
Yeah.
just the one.
Cosecant is CSC.
Yeah, can't see cats.
He says.
Can't see
No,
cats.
no. Cosecant is
Yes.
an acronym for can't see cat.
Can't see cat.
That one.
That's it. That's where it stops. It's not bouncing. Okay. Sinners can't see cats. Okay. Boom. Once you match those, cotangent, tangent match automatically. So you can't cosine. Sinners can't see cats. That's good. Sinners.
What is the order?
Or maybe the cosigner is secular. Or something like that. I don't know.
Ooh. I love it. So we'll do the very kind of mainstream understanding. Sinners can't see cats. That establishes that sine and cosecant are related. That's my favorite. I'm going to use that every year now. Gene, what do you have?
Mine's a playoff of Coca-Cola.
Beautiful.
Yeah, I know.
What do you got?
Show, K, Kateo.
Show,
Che,
che, like Che,
Kateo. CTAO.
Show, che, teo.
CHA. Heavy.
It's so. Show. Tell me the letters in order.
SHO. CHA. CTAO. Because cotangent adjacent over.
It's like Coca-Cola.
Show chocolate. Oh, that's silly.
Shokakatoa.
Shout at the structure.
AO.
We're still thinking of ways to remember secant and cosine related. All right, we're getting out of hand a little bit.
I have a visual aid.
This is the last one. Bring it up. What are we doing again? Find out a way. Just finding a way. Take cosine and secant. You can't, cosecant, call sine sin the secant cos money.
Yeah, or cost if you want to.
Oh, that's a T.
The secant costs money. Yeah, the secant costs money.
All right, you can look at it online at home. I'm gonna put it right. To all my people in Brazil, this isn't correct English, but it doesn't matter.
Wait, how many subscribers do you have from Brazil?
One. I always talk to the one person. One in Pakistan as well.
You can invite me.
Wait, do we have anyone else outside of the U.S.?
Yeah, but someone in Pakistan.
Do you have
There's
anyone from
somebody,
Serbia?
they watch it a lot actually. They didn't like the one video I did last year, the highlights of like funny moments. They gave me a thumbs down. This isn't that. This isn't that. Because they were all just outtakes from funny stuff. But funny, come on.
Best of 2018.
You don't even have a sense of humor. What's up with that? Okay, so bring it back. We're going to open up our workbook from yesterday's homework, page 45. I'm going to look at, let's look for number 1 through 4 to start. All this is going to come together right now. Number 1, perfect. 3 is a trick question. You'll never see anything like that ever again.
Okay, good.
I can explain it to you, but there's no deviation with x. So it ends up being 1 over 0.
Why?
Because they want you to sum out. They want you. The point of that is to recognize that a line isn't a triangle.
I tried to make a triangle.
Yeah, no kidding.
Yeah. Try to relate that within the context of a hard
My
problem.
5-year-old cousin knows that a triangle has 3 sides.
All right, let's bring it together. Bring it back. Bring it back quick. Write it down, please. Cosine of theta is what we're looking for. We know that this goes through negative 2, 7. Okay. So I want you just real quick. Go ahead and just make a Cartesian coordinate like this. X and Y. Where is this point located as far as our y values go, our x values go? Negative 2. Okay. So in essence, we could think of our unit circle right in the middle there. Units of 1 for the radii, all directions. And then how far up? 1, 2, 3, 4, 5, 6, 7. Here we go. So what we do for number 1, draw the line from the origin to that point. Now this next step is important. It's why we focused on the warm-up on the reference angle. Which is the reference angle here? I know that's going to be my theta of the triangle, right? So my reference angle is going to the x-axis. The quickest way to get the x-axis is here, right? So I know that's going to be my theta within my triangle that I'm going to draw next, right? Because the point out here is negative 2, 7. So I know that from the origin it has to go into, which quadrant is this? Oh, it's definitely second. Good. All right. Here's where all the stuff we did on the left board comes in. This is where everything comes in on the left board. Because when we draw the triangle here, right, and we reinterpret it down here, it's going to be with theta here. We're going to have 7 for the y and 2 for the x. Because we lose track of the negative value for the 2, we want to figure out what the answer is going to be just from this information. Right? We're looking for the cosine of theta in quadrant 2. Reference that chart over there. What is my answer going to be? The cosine of theta in quadrant 2 is going to be?
Negative.
Are you positive? Actually, wasn't good. More for you. You get an A.
Thanks.
Question? Sure. So this is it. I know that my answer, I'm going to circle this. My answer is going to be negative. So I can even go over here and say, under Shokaktoa, it reminds me of the Mayan words I can never say correctly. It's going to be negative. It's going to be negative, and we're also going to have a ratio right here between the sides from the triangles. We even know what sides are going to be included. What sides are included in cosine? So,
Jason.
you see it?
We don't know hypotenuse.
We're going to find that. Does everyone see how this triangle that I drew here relates to this triangle? It's the same thing, right? Here's the deal. We figured out what the sign is going to be in relation to where it falls on the graph. I know it's negative. All this that had the unit circle and the reference angle is now irrelevant. We're done with that part. Do you see why we're done with that part? We're going to depend on this triangle and trig functions. So, Gene, you're right. There is no hypotenuse, but let's label the other sides. What's this? Opposite. Think of a projector. What walls are you going to project on? The opposite wall. What's this? Hypotenuse always across from the right. I always note that first, then figure out the opposite, adjacent's left. Okay. So looking at this, how are we going to find our hypotenuse? We'll call this A. We'll call that B. We'll call that C. Pythagorean theorem. If you don't know it, you missed your freshman year. Pythagorean. C just has to be the hypotenuse. C has to be the hypotenuse. A and B, it doesn't matter. Well, if we take this, C would be equal to the square root of A squared plus B squared under the radical, under the root. I'm going to do it in a couple more steps. Okay? I set it up. A squared, B squared, C squared. 49, C squared. 53, C squared. C is? Square root of 53. We're going to have to rationalize the denominator here because the hypotenuse for cosine is on the bottom. Just keep that in mind, right? So we have root 53. Once we've filled in the triangle, create the triangle with magnitude only. That was only positive values. Great. Use the quadrant to find the sign for the answer. We do that, actually, we did that step 2 just because we were ready for that. You could put that in step 2. All right, so now finally, what was the adjacent side in relation to my theta? That was my reference angle here. Adjacent? 2. What was my height? Square root of 53. So we know it's negative. We know we have negative 2 over the square root of 53. Let's go ahead and clean that up. What should I multiply by? Over the square root of 53. Everyone see that that's really just 1, 53 over square root of 53. Or these two are 1. It's a special 1. Remember that root 53 times root 53 is 53. Think of it this way. Root 100 plus times root 100 is 10 times 10. That's 100. Anytime you multiply by the root of the same value, you're going to end up with that value. Yeah? Good. So we end up with negative 2 root 53 over 53. So I'm just going to go ahead and accommodate that here for our answer. Get out of there. How are we feeling? You're just smiling randomly. It's fine to smile. What was that thumb? Is up? You're moving. All right, give me some thumbs up, sideways down. Give me a real good vote for this compared to yesterday. Okay, if we see one more problem, is it going to probably bring it together?
Like on a different
kind of problem?
yeah, like 5 through 7 or like 8 through 10.
Wait, I heard 5 things at once. So, Ella, what were you saying?
I get the first one, but I don't get 5.
The 5 through 10 part. Okay. I'd rather do the 8 through 10 parts. The 5 through 10, essentially, that you're doing some calculator work there.
Is that just getting like sine of?
Yeah, sine of in radian mode 7 pi over 6.
That's all of it.
Yeah. Determine the specific determinant ratio for each. That just doesn't come in.
Wait, it's like it's the first one, -0.5.
Yeah.
Okay.
You could essentially find this from your unit circle. It's in the back of your book on page 149. Dog-ear that. Actually, dog-ear that so you can refer to it quickly. I put a little dog-ear. What else should I say? Let's do number 8. All right, let's do number 8. Let's do number 8. Hand up, Gene.
Yeah, I was looking at these goals here tonight, and I'm confused on how to do it.
What number?
That's the wrong page.
Yeah, I know.
Can you stop?
Well, we need to
Yeah.
Tonight's is in the textbook. It's already on Edmodo. It's a JPEG, so everyone can see it. But let's go on the homework from yesterday still. People have problems, they got to turn that in. All right, bring it back together. Bring it back together. You guys are really good at transitioning back to being focused. Let's keep that up. Number 8. Find the cosine of theta given, 1, that the tangent of theta is 2 over 3. And we're in quadrant 3. We're in quad 3. So just to get a reference of this, I know it's down here somewhere, quadrant 3. So we're going to go ahead and, let's see, 2 over 3 tangent. Remember, we know what this ratio represents. The tangent of theta is the opposite over the adjacent. The opposite over the adjacent. Opposite. Adjacent. So I'm going to assume it's down here somewhere. That's my terminal side. So which is my reference angle? How do I get quickest back to my x-axis? Go up. So I know that I'm going to go up. And that's going to be my theta. And that process is the same every time. You just look reference angle. You might get confused if you didn't know it was a reference angle, and you might say, well, it could be this way or it could be that way. And once you have a confusion where it could be one or the other, you just lack the confidence to, go for it. So now you know this is our reference angle. In comparison to this, it said the opposite was 2, the adjacent was 3. So I'm going to probably just move it a little bit that way. And we'll have this. The opposite is 2. The adjacent is 3. Here's my right angle. That's my theta. Okay. What side are we missing? Hypotenuse. So essentially, the only difference between this and the other problem is they tell us what we're looking for, and they give us some clues. The tangent of theta within the triangle is 2 over 3. But to place it correctly, you have to have this information too. It's in quadrant 3. And then also, you have to know that's the reference angle to get back to the x-axis, so that's my theta. You see how that's all linked? I think yesterday I did not say all those things as effectively. So 2 days sometimes for some lesson. All right, so we have a triangle like so. 3, 2, theta. Let's find this hypotenuse. What should I do? Does anybody see the Pythagorean triple here? Four plus 9. Oh, there's no triple. Just kidding. Oh, we'll call it C. A, B, C. All right, so we end up with C squared. We get 13. C squared. C is root 13. That tells me I'm thinking we're going to have to rationalize the expression at the end because I know what I'm working with. Working with the cosine. Okay. Now, since I'm trying to find the cosine, when we made this triangle, we lost all information about, well, actually, they gave us the ratios. You know, this would be a -2 usually. That'd be a -3, right? negative, negative down here. So I know that in my final answer, I have to say, okay, I know that we're looking for cosine of theta. In quadrant 3, it's going to be positive or negative. In quadrant 3, we're going to have a ratio over here. We got our triangle done. We forgot about the unit circle already, way a long time ago. So if I know this is root 13, and I'm here, I'm looking for the cosine. The cosine is adjacent over the hypotenuse. What's my adjacent side?
Oh.
First, it's easiest to see. The opposite is across. This is always our height. So that has to be the adjacent. Right? I heard a what, like, I don't, what? No?
Yeah, you got it.
Got it, okay. What goes on bottom? All right, we're going to change this up. What's going to end up being our final result when we multiply by this? 13.
Oh, sorry. That's also negative.
Negative. You know, I put the negative out there before I even put in my ratio parts. I'd suggest that.
Good work.
Right? Because any information we get towards the answer to start is going to be a good direction for that, Jackson.
We have like a fraction that can cancel out. Like if we had like 3 root 15 over 15, would we be able to like simplify that? Or?
No, because root 15, remember, is like the 3.8 something. Or
Yeah.
15 is 15. So they don't relate in a way that we can try to cancel that out.
No, I was like if it was like 3 over 15, and then there's 3 times root 15. Would we be able to simplify? Like if the 13 was changed to 15 on it, would we be able to simplify it?
No, sir. And we'd end up with 3 over root 15, so we go the same rationalized expression to get here.
Okay.
It would look just like this. Does it seem more doable now? You guys can do it a little better? Should I do one more problem, or do you want to go into classwork for the last, like, 7 minutes? Want to do a little bit of classwork?
Yeah.
Okay, good, good. So mostly thumbs up now? Where are we at? Okay. I like that confidence. No one's down. It's good. Good. All right, great job to my viewers in Brazil. Ciao.